This is going to be a tutorial on how to use the Open Reaction Database web editor. So we're going to start off by looking at how to define a single reaction using the web form. So here I've just pulled up the sort of homepage listing available datasets. We're going to be working with a reaction from the paper shown on the left. I already have this pulled up. So specifically looking at figure 1, this reaction table. I also got the supplemental information pulled up, which has some additional details that we're going to need to use the form. We'll keep these open and refer to them while we define the reaction. So we're going to start by creating a new data set. Here we just enter a name, which summarizes what this corresponds to. We click on that data set and we come to this form. So here we see data set attributes include a name, ID, description. So we give it some name that is an easy reference to what it contains. We might give a little bit more information in the description about which specific figures or reactions are entered in this particular data set. So I paste in, including the DOI. We're going to go ahead and save it and add our first reaction. Clicking on that reaction then takes us to the full reaction page. There's a lot going on this form, so there's a sidebar on the left so we can show individual sections one at a time, going from identifiers to inputs to setup, to conditions to nodes, observations, workups, outcomes, and provenance. And we'll see what each of those sections means as we enter this particular reaction. Not all of those will be relevant to every given reaction we decide to enter. The first thing we look at is this validation display. So we see that there are two errors, right? It says that the reaction should have at least one input and at least one outcome. There are a lot of these different validation indicators throughout the form that tell us when we've entered something that is deemed acceptable or unacceptable by some Python-based validation scripts we're running in the backend. And we can refer back to each of these indicators. Throughout the form, they'll automatically update. This overall validation of the reaction does not automatically update, but you can see the blue validation button, which we can use to manually trigger it when we want to recheck what we've entered. So as we start going through the form now, the first thing we'll do is add a reaction identifier, in this case, just a name of the reaction type. We'll then move on to the inputs, where we actually need to define all of the different stock solutions and components that go into the reaction. So the first one we'll enter is the alcohol, which is entered as a stock solution in THF. We'll add a component to this input. The first component is going to be the reactant itself, so the alcohol, not the solvent. To define the reactant, which is the limiting reactant, we're going to go ahead and draw it. That's going to pull up a window of Catcher, and so we can actually draw the compounds and not need to worry about entering a smile string directly. So we're going to draw this compound, which is 1A on the left. Once we're done, we hit Done Drawing. That's going to automatically populate both the smiles and a mole block identifier for this component. Here I'm just going to clear the mole block because we don't really need it in this record. So now moving on to the amounts. This reactant, if you look at the SI, is added with 0.1 millimole. So we go ahead and enter that. We don't enter a precision because it's not specified. We could add some preparation, so how this component was prepared, but we don't have any information about that in the SI. Likewise, we could specify the vendor. We don't have that specified in the SI either, so we keep that blank. We add the next component, which is going to be the solvent that this alcohol was prepared in for the reaction. So the reaction role is solvent. For the identifier, or just for convenience, we're going to look this up by name. So we just type in THF. That's going to automatically be resolved by PubChem. We can remove the name if we want. It's not necessary. And I'll delete that details field because we've confirmed this is the right product, right? This is THF. And so we don't really need that detail. Now here we enter the volume. So this is 125 microliters. And importantly, we check that it does include solutes. So that's a total volume of the stock solution. And you can see already we're adding a preparation type. So if you look at the SI, it specifies sort of in the general information section that the solvents were dispensed from a dry solvent system. And so we can record that information as a preparation. The addition order of this input, this is the first thing that's added. Again, if you look at the SI, things are added sequentially, and this is listed first. We don't have any other information about the speed or how it was added, and so we leave these unspecified as well. Moving on to the next input, we're going to specify the base. So in this case, the base is a pure component, so we're going to label this as a reagent. We can specify it by drawing it or looking up by name. In this case, we're starting with DBU, and so we just type in the name. Again, this gets resolved by PubChem. We can delete these unnecessary details once we've confirmed based on the drawing that this is the compound we want. So here, maybe we leave in that it's DBU, and we'll see why we might want to remove that later. So it's 1.5 equivalents, which in this case is 0.15 millimole, so we specify that, and there are no additional preparations we have to worry about. Next up, we're going to specify the addition order again. So in this case, the base is added third. So again, if we go to the SI, which is where these details are actually contained, we'll see that these components were charged sequentially. In this case, the alcohol is first, the sulfonyl fluoride solution is next, and then finally the base. So that takes us to the third input for this reaction. And so this is going to be specifying the sulfonyl fluoride stock solution. So this again is going to be a stock solution with two components, right? The sulfonyl fluoride reactant or reagents. It could really be categorized as either. These aren't terribly precise definitions, but because it contributes a heavy atom, right, fluorine, we'll go ahead and list it as a reactant. Here, the easiest thing to do is to draw the sulfonyl fluoride. So we'll pull up Catcher again and start drawing it. So here I don't actually use Catcher very well, so I mess up doing this drawing. So when we actually hit done drawing, I'll see that this is not really the structure that I wanted. So what I'll do is, first try to salvage the drawing, but otherwise, if I directly work with the identifiers, I can fix it in this case. So I'll remove the mole block, and instead I'll directly edit the smiles to fix it, right? So just to make sure that the drawing was properly resolved. And you can see that we have the separate rendering here, besides Catcher, to confirm that this is the right product, or sorry, right species. So now we'll go ahead and manually enter that smile string. So the fluoride is 1.1 equivalents, which here is 0.11 millimole. Again, no precision is specified. We don't have any special preparations or vendor information here to worry about. Next, we'll add the solvents for this component because, again, this is a stock solution, so it's also THF. We'll just work with the smile string. The volume of this solution is 125 microliters again, and the preparation in this case is dried. Right? Again, the solvent is dried. So removing that detail, and then listing the preparations, selecting dried. This stock solution was added seconds, again referring back to the SI. Still no information about speed, device, or anything like that. So we've defined all three of the inputs to the reaction, and if we go back up and click the validate button, we'll see a partial drawing of this reaction, summarizing what was added. We still see we do have an error, there's no outcome, and so we'll get to that later. But working our way down the list, we'll next talk about the setup. So in this case, the reaction was run, again referring to the SI, in a vial. It was run in a glass vial specifically, and the volume of that vial was about 1 milliliter. If you look to the left, right, it's really specified in terms of the dimensions, but the corresponding volume is about 1 mil, so we can put that in. This was not an automated setup, and so we specify false for that. We could also just leave it blank. So we click down to conditions and start specifying the temperature, pressure, stirring, and other aspects of the conditions. So going to the relevant section here, we see it's stirred at 600 RPM, room temperature for 48 hours. I also noticed that the vials were capped, and so that's important. I go back up to the setup, and I add an attachment to the vessel, noting that it is capped. Okay, we're going to go back up and hit save just to be safe. Now, going down to the conditions, the first thing is to specify ambient temperature. We encourage that even if it's ambient, to estimate room temperature. Here, this is a complete guess, which I don't advise. I'm just saying it's 20 C plus or minus 5. For the pressure, This is just a capped vial, so it's sealed. The atmosphere is just air. It wasn't purged beforehand. It was closed in ambient conditions. And for the stirring, right, it's specified that we have a stir bar. It is spinning at 600 RPM, which I say is qualitatively high. We could put in details about the size of the stir bar and the material if you would like. So we don't have anything else to specify about the conditions, right? Any details or special considerations. So we move on to the notes. There are a number of different things we can specify, including safety notes and extra details. None of those are defined here, though. And the next section is observations, which are any images or notes taken during the experiment itself. In this case, again, there's nothing specified in the paper, so we just skip this and move on to the workup section. Workups are anything that was added or any processing steps done after the reaction itself, but before any analysis or characterization of the product. In this case, if we look at what happens, again, looking at the SI, we do add in a stock solution with an internal standard before we take an NMR. And so this is an addition workup step. For an addition workup step, we have to specify the inputs. So expand the input field, we add our first component, and we specify what that component is, right, that one fluoronaphthalene, so we can do that by drawing or by name. In this case, it's easiest just to type it in by name. So put that in, it's going to trigger the PubChem API to resolve it. We can confirm that is the right structure that we wanted. So we remove those details. We then specify it's an internal standard. That's a specific reaction role. We know that it's one equivalent, so that's going to be 0.1 millimole for this scale of reaction. Then we add in the next component, which is going to be our chloroform, right? This was prepared in. There are no special preparations or vendor information for the internal standard. So here for chloroform, we're going to look this up by name. Again, this is a very convenient way to define the components. We don't have to worry about writing smiles ourselves. So we specify that this is going to be a workup reaction role, right? It could be a solvent, but it's just used in the workup, so we put that instead. And then the total volume is 250 microliters, which we assume does include the solutes. So we specify that. So that's the only workup step that is specified. We could say, under what temperature was this added, addition speed of this workup, but we don't have any of those details. Again, stirring, we just assume that it's mixed, but there are no details we need to specify. So outcomes are any analysis or product identification. This is where you define the reaction time. So this is an outcome observed at 48 hours. We don't have any information about the conversion in this case. And so we move on to defining the analyses and the products. So first we have an analysis that we add. We give it a name that is only used for convenience. This name doesn't need to be formatted in any special way. The type is an NMR, but it's not proton or carbon, so we specify NMR other. We provide some extra details to say it's a fluorine NMR. And we'll give a little bit more information about the internal standard. Even though that information is captured elsewhere, it doesn't hurt to put it in this details string field. So in this case, we actually know the instrument manufacturer. That's specified in the SI, as it usually is. We could also specify the field strength here if we would like, and the details as well. We do know an internal standard was used, right? We just put that in, 1 fluoronaphthalene. And so here we could add processed or raw data, but that's going to be considered out of the scope of this particular tutorial. You can see if you explore this on your own that we can upload processed data or raw data either as files, or we can enter specific strings or floats and different information. And so, for example, we could include a peak table represented as a string for this NMR. For the processed data, for the raw data, we could upload our original FID. Because we don't have access to that, we instead just move on to defining the product. So for the product, we draw it again using Catcher. This is going to be the fluorine equivalent of the alcohol reactant we specified, so we'll just redraw this. And this is product 2A on the left. So we're done drawing. We again confirm that this is what we want. I'll remove the mole block for convenience, and again, we'll see later why. We don't have an amount to specify here. This wasn't an isolated product. And so instead we move on to say whether or not this was the desired product. In this case, yes, it was. And then we can specify yield, purity, selectivity, and other details of the isolated product. So the yield in this case is about 40%. Again, this is the top left corner of figure 1b. For the precision of the yields, we rely on an estimate from the SI that said the variance was about 4.8%. So again, this isn't terribly quantitative, but we'll put this in just as a point of reference to note that 40% isn't very precisely known. We have no additional information about the isolated product. So next we define what analyses were used to confirm the identity. In this case, we only have one analysis, so that's easy. Likewise for the yields, what was used to quantify the yields? That was the 19F NMR of crude that we just defined. You can imagine there are going to be situations where we have multiple analyses, right? Maybe we've done high-res mass spec, NMR, and LCMS to characterize the products. Maybe high-res mass spec and NMR were used to confirm identity. Maybe purity was determined through LC. And so we have these different dropdowns just to give us the flexibility to specify which analyses were used to quantify which aspects of that product that we've just defined. So now we move on to the final section of provenance. So provenance is going to tell us information about who did this reaction, what publication does it correspond to, and who created the record. And that last part is particularly important for this database effort because we'd like to have some tracing of who's defining examples and how to contact them if there is a potential mistake that needs to be resolved. So I'll specify it right now. I'll put in my name, I'll put in my email, I'll paste over my org ID, and then the organization, and then any additional details about the creation of this record. So next up is going to be enumerating a full data set. Right? We've just defined one reaction example from this paper, but we're going to now want to define the entire table from figure 1. The first step for this is to scroll back up to our full reaction. In this case, we can validate it, and we'll get the full drawing of what the reaction looks like. And we can click the download button to download this reaction as a PB text file. And so this is going to be a text representation of all the information that we've just defined. So if I pull up that text window, what that file looks like, we sort of see the data version of what we've just put into the form. So all of the normal fields and information that we've specified. I've also in advance prepared this spreadsheet, which has rows for every reaction that was run in the table corresponding to figure 1. So we have a column of alcohol smiles, sulfonyl fluoride smiles, the base, product, and yield. And the way that we enter these is we use the column name and we put in placeholder strings. So you'll see on the left, alcohol smiles we've written in contained within $signs. We'll also do that for the sulfonyl fluoride smiles. So again, keeping the quotation marks, but putting in the column name between $signs. For the base, we do the same for the smiles field. Here we also need to delete the name identifier because not all of these bases are DBU. We could also have a name column, but we don't in this case. Then we move down to defining the product smiles, right? Because each reaction might have a different product smiles. Here again, in $signs, the name of the column. And then the product yields, instead of 40.0, we don't need quotation marks in this case. And I'll note that the column names can have any letter or number and underscores in them. So with these two files, right, we have the CSV spreadsheet and we have this placeholder reaction PB text that we've modified with these $sign delimited placeholders. So we go to the enumerate dataset option of our homepage. So we're going to define a new dataset where we first upload the reaction PB text templates. We then upload the CSV, which is open in Excel here, and it will create this new dataset, right, that I've called Nielsen Figure 1. So in this case, we see that we have 80 reactions already populated. These are the 80 rows of the spreadsheet we uploaded. So I'll give this a name. Again, this dataset starts off blank except for the reactions that are created from the spreadsheet and the template. We'll save that. We'll go ahead and open one of the reactions. In this case, we'll start with 0, which is the template that we defined. So when we open up this reaction, we can see, again, the summary at the top. It looks great. It looks like exactly what we specified. We can move down to the middle of the data set, see a different reaction from partway through the table. So we've got a different alcohol, a different base, different sulfonyl fluoride, and we can see, in this case, it's a 2% yield example just looking at our table, yes, that is one of the entries that we specified in the CSV. You can also go all the way down to the last reaction, where again, we see the reaction pulled up. We have all of the fields populated based on what was defined in the CSV in the template. And see that's the bottom right corner in the figure. And so, yes, this is the 58% example. So all that's left to do here is exporting this data set we've just made. So from the data set, it's very simple. We can just go ahead and click the download button that's at the top. So again, we have 80 reactions. We hit download. That's pulling up the file browser. We'll save it as a PBText. And if we open up this PBText, which is now defined for the data set, what we see is that it's a very long text file which contains each of the reactions, right, each of these 80 reactions, with the appropriate smile strings, product yields that we specified in our CSV. So that's the end of this tutorial. Now, depending on when you're viewing this, the form might look a little bit different, but the overall workflow is going to be the same. Right, we have this pretty long schema that lets us specify many different aspects of a chemical reaction. And we have sort of the graphical way of entering this data. There's also a programmatic way of specifying this, all using Python code. There are many examples of that in the GitHub repository. We also saw how you can define maybe a high throughput data set by combining a template reaction, which we've entered on the form. We've modified the PB text a little bit to specify where the placeholder should go. And we've defined a CSV that contains all of the examples to very quickly populate this full data set. So that's the end of this tutorial. And thanks for listening and for your interest in the Open Reaction Database efforts. We have some more information about how you would actually take this downloaded dataset PBText and submit it to the official data repository available online at openreactiondatabase.org, as well as some additional information about the schema and the overall effort. And if you have any questions about the material here, please feel free to reach out to myself personally or to the governing board or advisory board for other information about how you can get involved. Thank you.